The moon's surface. Time on the surface of the moon runs consistently faster than on Earth by about 56 microseconds every day. This is another consequence of Einstein's relativity, but with a different outcome than for the ISS. Two effects are at work. The moon's weak gravity speeds time up, while its orbital velocity slows time down. Here, the balance is different. The effect of the moon's significantly weaker gravity is far more dominant than the effect of its speed. The net result is that clocks on the moon tick faster. This might not sound like much, but the GPS satellites we rely on drift by similar amounts and require constant correction to prevent your map from guiding you into a lake. As NASA plans for permanent lunar bases, this time drift becomes a serious logistical problem. If Earth and moon clocks drift apart, timed rendezvous could fail, and data transmissions could be corrupted. To solve this, space agencies are now working to create an official, coordinated lunar time to ensure all future missions can operate on a single, reliable clock. Number 9. The Mount Athos time zone. On a remote peninsula in northern Greece, the day officially begins at sunset. This is Mount Athos, an autonomous monastic state that has run on its own time system for over 1,000 years. They use Byzantine time, where the 0 hour is the moment the sun disappears below the horizon. This means that when the rest of Greece is settling in for the evening, the monks on Mount Athos are just starting a new day. An hour after sunset is 1 a.m. It also means that the time of midnight, or 6 a.m., changes every single day, shifting with the seasons and the length of the day. About 2,000 Eastern Orthodox monks live here in ancient cliffside monasteries, following a tradition that dates back to the Byzantine Empire. To visit, you need a special permit to enter this place that exists within a modern country, like a historical glitch. Once inside, your phone's clock is useless. To know the time, you must ask, how many hours has it been since sunset? Number 8. Pripyat, Ukraine. After the Chernobyl reactor exploded on April 26, 1986, the 50,000 residents of Pripyat were given 2 hours to pack. An announcement told them it was a temporary evacuation that would last only 3 days. Nobody ever came back. Everything stayed where it was left. School books are still open on desks, waiting for students who are now middle-aged. A Ferris wheel, set to open days after the disaster, rusts in an abandoned amusement park. Nature is reclaiming the city, but the radiation is doing something strange to the process of decay. The microbes and fungi that normally break down organic matter are struggling to survive. Trees that fell decades ago are barely decomposed. The surrounding red forest, where acute radiation killed the pines, is filled with dead trees that are still standing and still barely rotting. In this irradiated landscape, the natural cycle of death and decay moves at a different, slower pace. The clocks in Pripyat are all frozen, each stopped at a different moment on that fateful morning. The city couldn't agree on the exact moment time stopped, it just knew that it did. Number 7. The International Space Station. If you spend 6 months on the International Space Station, you will return having aged approximately 0.005 seconds less than everyone you left behind. This is real measurable time travel into the future, predicted by Albert Einstein. Two of his theories are at play. Special relativity states that the faster you move through space, the slower you move through time. The ISS hurtles along at 17,500 miles per hour, causing time for the astronauts to slow down. But general relativity states that gravity warps space-time. The farther you are from a massive object like Earth, the faster time passes. These two effects are in a constant tug-of-war. For the ISS, the effect of its incredible speed wins by a tiny but decisive margin. After astronaut Scott Kelly spent 340 days on the station, he returned to Earth measurably younger than his identical twin brother Mark, who had remained on the ground. They share the same DNA and the same birthday, but thanks to relativity, they no longer share the exact same age. Number 6. Big and Little Diomede Islands. Two small islands sit in the Bering Strait, one Russian, one American, separated by less than 2.5 miles of water. Their real significance is strange. The international date line, the boundary separating one calendar day from the next, was drawn to zigzag directly between them. This has a profound consequence. Big Diomede, the Russian island, is 21 hours ahead of Little Diomede, the American one. The difference isn't a full 24 hours due to their separate time zones, one anchored to Asia and the other to North America. If you stand on the American island on a Monday morning, the people on the Russian island are already waking up on Tuesday. For this reason, they are called Yesterday Island and Tomorrow Island. Little Diomede has a community of about 80 residents. In deep winter, the sea can freeze solid, forming a temporary ice bridge between the two islands. For a brief, dangerous window, you could theoretically walk from the United States to Russia from Monday to Tuesday. You would cross not just a national border, but a calendar day with every step. 1 foot